Good morning, this is Ms. Billerbeck, and we're going to play around with some parabolas today. So first we're going to look at the standard form of a parabola, then we're going to look at the factored or root form of a parabola, and then finally we're going to look at the vertex form of the parabola. Now for Singapore Math 8, we're only going to be dealing with the standard form of the parabola for Chapter 8, but I thought you should know about these other forms just in case, okay? Here we go. All right, so this is the standard form of a parabola. Y equals ax squared plus bx plus c. And I have a few sliders going on right here. So let me just make this 1 right now. So there we go. And we're gonna just, okay, so we have this form of the equation, and if you notice, this c is at 1, and look at that. That's also 1. So this is showing us the y-intercept. Okay, so now I'm at -1, and the y-intercept's at -1. And what A does, let's see if I can, so let's move B around. Isn't that interesting how B moves? Okay, so let's move this over here, and we're going to move B around. Oh, that's a nice one. Okay, so if you notice, I've got the y-intercept at C, and now I have B at -3. Now I mentioned that A is kind of like a slope. So if I had an axis of symmetry here, this would be very similar to a parent, well, a parent graph goes right through the origin, which we'll look at later. But so let's look at the slope. So as I make a larger number, this is going to be a narrower parabola. See how narrow that's getting? Okay, so it's like a rosebud. You know, it's very steep in slope. Okay, but as I get closer to below 1 and closer to 0, look how wide that parabola is getting. Look at that. That's huge. Okay, and if I go to 0, I have just a straight line. Okay, that means that this whole term is gone. So then I have a linear equation with a y-intercept at 2. Okay, so, and then if I go and do a -a, look at that, it turns upside down. Okay, so that's when a is less than 0. And when a is greater than 0, it is upward. All right, now let's look at a factored form of the equation. So this is showing me roots. So right now, P is 1, Q is 1. So they both have the same root. It's called a double root when P and Q are the same. Okay, so if I wanted to show you a parent graph, I would make P 0 and Q 0. And they'd have a double root right there. And A is 1. So basically, this is my parent graph for all parabolas right there. So as I change this root to something else, it's just right there, gives me a 3, and it's crossing 3 here, but I still have a root at 0 here. If I change this root over to a negative, then I have a -2 here. So this gives me 2 points. And I also know from these roots that my axis of symmetry is right between them. So let's say I had this at 2, I could see that really quickly. So see how this is 2 and that's 2, and the vertex is right between them. So there's a distance of 2 from 0 here and a distance of 2 from 0 here. Okay, so, and the same with every point here. So my axis of symmetry is the y-axis here. So what we could do, if I wanted to know what the axis of symmetry was, if I had a 4 out here, or there we go, 4, then my axis of symmetry would be -2 plus 4 divided by 2. I'd take the average of the 2 points. So -2 plus 4 is 2, and then divide it by 2 gives me 1. So we would expect this vertex to be at 1. So let's see where it's at. It's at 1, see? So you can find your vertex. Once you know that the vertex, the x value of the vertex is at 1, you just plug it back into this equation here to find out what the output is for x is 1. And then you've got your vertex. So you have 3 points. You have the 2 x-intercepts and the vertex. So that's the cool thing about this. And then if a is negative, take a look at what happens. Boom, it goes upside down. So, and when a is 0, look what happens. Nothing. It's just the x-axis, or y equals 0. Okay? Because everything is going to be 0 if 0 multiplies by it. Okay, so if a is positive, it holds water. If a is negative, it does not hold water. Okay? It's concave down or concave up. All right, the last form of a quadratic equation is the vertex form. So if we notice right now, I have a equals 1, h is 1, which is my x value, and k is 0. Now, if I want to have this as a parent, I just put the h as 0, and there's my vertex. If I want to change this up and put this at 3 and then make my k 2, let's make it 2. There you go. So my vertex is there. So the only thing it's doing is changing where the vertex is by changing h and k. Okay, so if I go back to the parent, I want to show you the slope a little bit more. Okay, so when a is a larger number, it gets very narrow. See that? Okay, it's like a tight rosebud. Okay, but when we have it at 1, that's our parent. Now when we have 1, it's like a wilting rose. Look at that, it's a wilting rose, all until a is 0. Okay, so that a wilting rose is just a fraction of its beauty. So if you look at a decimal value, it's like a fraction that's between 0 and 1. Okay, and then when we have negative values, the same thing. It's pretty close to the x-axis when it's between 0 and 1. Okay, and then as soon as it gets above 1, it becomes very narrow again. Okay, so that's it for our parabolas. And let's see if there you go. I'm going to start animating that so you guys can see it. And let's animate this one. There you go. That's what H does. And now we're going to add in K. Boom. Look at that. It's going way. Ooh, it's gone. Hopefully it comes back. There it is. It came back. All right. So there you have it. Parabolas. Enjoy. And you have a wonderful day. Bye-bye.